Well, thank you for having me. So yeah, I'm gonna get to it here. Now, what I'm gonna do today, I'm gonna kind of talk about well, I'm going to talk about Microsoft strategy for AI, kind of soup to nuts. I mean, a lot of times you have these kind of isolated, like, you just came out of that M365 Copilot presentation and talking about that, or maybe this one about Copilot Studio or that one about Foundry. And I am going to kind of touch on a whole bunch of different things, but really talking about our overall strategy, not just even Microsoft's overall strategy, but where the world of AI is about to go, what's happening right now. So I am, through the course of this, going to touch on a bunch of things, and I don't have any slides. So we're not going to be doing slides here. We're actually going to be doing this live. That is the plan. So hopefully the Marriott Courtyard, Miami South Beach Wi-Fi holds up. We're going to find out real quick. So here we go. Let's see. Okay, cool. So I'm going to start with a couple of appetizers before we get into the main meat of it. And so this one's for you, Vesa. Well, I'll let myself speak for myself.
Hei ja kiitos, että olette kanssani tänään. No, englanti on ainoa kieli, jota puhun sujuvasti, mutta tekoälyn ihmeen ansiosta voin nyt puhua melkein mitä tahansa kieltä omalla äänelläni. Kun kuiskaan, se kuiskaa kanssani. Kun huudan, se huutaa kanssani. Tämä tekoäly tulee muuttamaan maailmaa.
So this is our video translator, I should say, and this is the video translator with lip sync. Now I made myself in this case speak Finnish, but I mean I can make myself speak a vast number of languages. I don't even know how many are in here.
I think we might have lost you for a second, Marco.
Yeah. Yeah, I know something strange did just happen. Now, you all can hear me again?
Yeah.
Can you hear me?
We can hear you. We can hear you. Yes, we can hear you.
Okay. So Teams is doing something a little strange here, but hopefully it holds up. It did do something strange, but I'm going to hope that this doesn't get in the way here. So anyway, so that is the video translator. This has been available for a while. It's available now. It does do lip sync. I don't know how well that came across on Teams, but it does now. If you're a face-on single speaker video, it will not just change the audio track, but it'll change your lips, and it does match your inflection. So here when I whispered, it whispered. When I shouted, it shouted. You may not have made that out from the language Finnish, but you could hear it. So it's fascinating what you can do with this, for training videos, for marketing and stuff like that. And this is actually available live. I mean, if we look in this Teams meeting, which I hope now, actually, because this is live, I don't know if it'll show. Let's see what happens. Yeah, so you can see I have this option over here. It says turn on interpreter for me. So I could do that. Now, if I did that, none of you would hear it, so there would be no point in that. That's why I have this video right here to show you what it looks like.
Nice to see you again.
Let's turn this back a little bit. All right, Manya. Well, you can't see this, but I am going to go to language and speech, and I'm going to turn on my AI interpreter. And as you can see, my settings are such that it's going to interpret to English. So now, Manya, you may speak any language you choose.
Hi, Marco. Schön, dich wiederzusehen. Ich freue mich sehr, euch alle kennenzulernen. Nice to see you again. I'm very happy to meet you all. This is a fantastic opportunity to work together and shape the future of AI together.
So I think you get the idea with that, but that is the real-time interpreter that is now built into Teams, at least if you have the higher level versions of Teams. And now more and more of our customers are starting to pick this up and use it, which is kind of cool. Well, I've been using it for like a year and a half, to be honest, but it just really became available to the public in May. And so now you're starting to see people use it. Now, if we deconstruct this a little bit and look at how it works, it's actually kind of interesting. First of all, when you turn on this interpreter, you set your destination language. There's a choice of, I think, 10 destination languages. So it doesn't have every language that the Azure API supports, but it has the 10 most common ones: English and Chinese and Korean, Japanese, and French and Spanish and so on. But you set your language. So here you see I set my language to be English, like so. But I didn't tell it what language that Manya was going to be speaking. In fact, I have versions of the same video in all kinds of different languages where the other party is speaking Japanese or Chinese or whatever. The way that it works is that there is another Azure API that's going on up front here, and that's called the Auto Language ID API. So the first thing that it does, for the first couple of seconds that she was talking, it was resolving what language she speaks. And once it resolves that she's speaking German, then it engages the German to English translation module. And by the way, that is a dedicated model. We're not using GPT to do these translations. That would be a little bit too high latency and too high cost for the like tens of millions of users that we have on Teams. And so we are using dedicated language pair models to do this translation. And we're using the same personal voice technology that you saw in the video earlier to mimic her voice. Now, as we go on, I mean, if you're listening to this, there is a delay. And there will always be a delay. I mean, for those of you who are Star Trek fans, yeah, in Star Trek, as soon as the Klingon opens his mouth, he's speaking English, but it can't work that way. It doesn't work that way. In part because of word order differences between different languages. Now, the average delay to translation stands right now at 3.95 seconds, which is a notable number because that is the same average delay that you would experience with an expert human simultaneous translator. So we have managed to match human speed in translation, not necessarily human accuracy. I would say this is probably, depending on the language pair, 80 to 85% accurate. A really good expert human simultaneous translator is probably 95% accurate. But I do use this quite a bit, especially with our customers and partners in Japan and Korea, where they don't really speak English very well, and I don't speak Japanese. So it definitely gets the point across. I mean, it changes the game for business. Now, this thing, I'm showing it in Teams. This is now available as an API. So we've wrapped up all the little APIs that it uses in here because it's using the auto language ID, the translation API, the personal voice API, all that stuff. We've wrapped it up into the real-time translation API that is now actually available as a service on Azure. It's in public preview as of, I think, a week ago. And so you can take this same functionality and put it into other applications, not just Teams, but you can put it, for example, we have some customers that are starting to put this kind of thing in their call centers. And so that can be an effective way to provide customer service to your customers that don't speak the same language as you. And for the last appetizer, I will actually use this here. Let's talk about the GPT real-time model. This is the new GPT real-time. This came out in August. So this is the, I think, fourth iteration of this model, but over the course of the next year or two, this is going to change how we interact with AI because it works like this. Hey, can you hear me over there?
Loud and clear. I can hear you perfectly.
Yeah, cool. So tell me about SimCorp.
Absolutely. SimCorp is a global provider of investment management solutions.
Yeah, actually, Vesa Nopinen is here. Can you say that in Finnish?
Totta kai, ilman muuta. Joo, Vesa on todella tunnettu.
Actually, no, switch to French.
D'accord. Je passe au français tout de suite.
Okay, actually, you know what? Switch back to English. Tell me a joke about SimCorp and then laugh at your own joke.
All right, back to English it is. Here we go. Why did the portfolio manager love SimCorp so much? Because it always kept everything well balanced. No margin for error.
All right, well, that wasn't a very good joke, and I didn't expect it to make a very good joke. But my point of that, and I have it set to SimCorp right now because I will be doing the keynote of SimCorp's event in a couple of hours, and that's why I just left this on my screen like this. But this is a GPT real-time model, and in a little while, I will show you a real application of this, or this in the context of a larger application. Here I'm using the raw model itself, and that's not really how you're going to use it under most circumstances, but it is super quick. So it's very low latency, it's interruptible, it speaks just about every language that I have tried with it. And it's pretty good. And one of the reasons why I made it make a joke is not because I thought it would be funny, but because I wanted it to laugh. Now, what's interesting about this model is this is not like, I mean, obviously we've done speech-based AI for a long time. Anybody who has Siri on their phone knows this. But the way we've done it up to this point is a little bit different. We did it as a sandwich. So you'd have speech to text on top, that feeds the text to the model, and then the model feeds text out, and then we text to speech it. And that comes out sounding super robotic because it loses your kind of inflection on the way in, and it just comes out flat on the way out. This is a direct audio in, audio out model. So my voice is being tokenized going directly into the model, and its voice, so to speak, is coming directly out of it. And that actually, well, it makes it faster, a little lower latency, but it also makes it a lot more natural sounding. And so, you're going to see and interact with more and more interfaces like this going forward. Okay, so now to the main meat of this. Let's talk about the overall agent strategy. Now, here I am. I asked, "What am I doing with Visit today?" And it answered that. This is M365 Copilot. I'm sure you've all seen this before. Uh, and this is, what people think that M365 Copilot does today and it does. I mean, you could use it to answer questions like this. And of course, it is grounded to my email, my calendar, and all these things. And so it knows what I'm doing with Visit today. And then he sent me this invite and that kind of stuff. But that's not really where this is going. I mean, that's where it was. And, back in 2023, this would have been revolutionary, but it's 2025. And where this is going really is over here, this agents bar on the left-hand side. Now, M365 Copilot has the researcher agent in here. And so that is, that you could do deep research. It's like ChatGPT, except that it can see all your SharePoint documents and your emails and stuff like that. And I actually use this researcher myself. Ironically, my most common use of it is to find people in Microsoft that are doing certain things. Like if I need to find somebody, I'm like, okay, research agent. Like I needed to find the person who was leading sales for higher ed. So I set the researcher agent to that task and it went and did it. The analyst agent can do math and stuff. You can give it spreadsheets and it can make pivot tables and those kinds of things. And then there's this retail supplier management agent. I built this myself. Actually, this is not one agent. To be honest, this is actually 8 different agents, and I can use it to like manage my contracts and stuff like that. But the idea of this is that M365 Copilot, what it's going to be, and what it's already kind of becoming, is a front door for your AI. And that means a front door for your AI agents. And those are, the ones that are built in, like the researcher and the analyst one, but it also means the ones that you build, like the retail and this one here that I got on the screen. Or this one over here. This is the CB Insights Strategy and Research Agent. Nobody at Microsoft built this. This is a third-party agent. And so increasingly, you're going to start to see third-party agents appearing as eligible agents in M365 Copilot. So, other folks at Microsoft, I think, have a DocuSign one. There's like an Adobe one in here. And so this will increasingly become your kind of portal to the world. And that's going to be a trend, both in the consumer side and on the business side. So M365 Copilot obviously is on the business side, but then you can think about these things like Menace that become your general purpose agent and your kind of portal to the world on the consumer side. I don't know if Menace is going to be the winner in that space, although they are relatively early to market and it does all kinds of interesting things, which we'll get into in a moment. But anyway, so general purpose agents are increasingly becoming a thing. And before we even get to, and I'll talk about creating it, how you create agents and our strategy with that and all that stuff in a minute. But, before you start creating agents, the first thing you got to do is just see what happens if you try it in here. And I have a concrete story about that I'll show you later on, which is interesting. But anyway, because increasingly, the base capabilities in the general purpose agents will be able to do more and more. Now, already they're starting to be able to, for example, I can go into the chat here and I can make it like schedule something in my Outlook calendar now. At least I can here at Microsoft. I don't know if that's generally available, but in any case, I can say, make me a meeting with this and open in at, whatever time, and it'll go do it. So it'll be able to do more and more things that you won't have to build agents for anymore. And this is a trend. I mean, you've been seeing this since 2023. Back in 2023, if you wanted it to just do like what I had originally on the screen there, answer the question about my whatever meeting, I would have had to build a custom agent for that. And then it just became embedded into Copilot. And this is going to keep happening where more and more capabilities will be built into the base of these general purpose agents that you won't have to build anything anymore. But when it comes to creating an agent, I mean, in Copilot itself, there is already a minimalist version of Copilot Studio, which hopefully will load on the screen. Here it comes. And this is managed by a company's IT. And so in here, and here I have no special permissions here. I'm just a regular old user. And in here, I can make an agent that, I can give it some websites. I can make a knowledge agent. Our IT has allowed us to connect it to ServiceNow, for example. So we use ServiceNow to manage our laptops and stuff like that. And I can make an agent that can look up ServiceNow knowledge or tickets or those kinds of things. And even the janitor at Microsoft can do that. So the idea is to sort of democratize this in a limited sort of way. And one major limitation of this interface, well, our IT at least did not enable any actions in here. So if I wanted to make an agent that does something in ServiceNow, well, I can't really do that here. because I don't have that option, in part because my IT didn't give me that option. But this will be, I mean, this is intended to be a limited environment. Now, if you look at what we've done with Copilot Studio, take a look at while this loads up, and I do hope it loads up. Here it comes. Look at the environment that I'm in. Now, this is interesting. This is something that we did at Microsoft back in May. We have lots of corporate environments. There's a ton of them in here. But what we started doing is we started making personal environments for everyone, at every Microsoft employee. And the idea of that, and I would recommend those of you who are in a position to do this also. This is my own domain here. This is my own little environment. In here, I can make agents for me. Now, I can't just make an agent and share it to anybody at Microsoft or in the world with this. There's a whole, IT process I have to go through to share an agent. But in here, I can experiment with this stuff. I can see, oh, look at all these other knowledge sources, not just the ones I saw in M365 Copilot, but there's many more. Right? I can do SAP in here and Zendesk and Confluence and all these things. And there are tools here that I can use. So like here, if I do want to do something with ServiceNow, now we're talking. Like I actually totally can over here create a record in ServiceNow with this. Oops. Now it's worth noting too that agents do not have to be chatbots. We often think of these things as being chatbots. They don't have to be. There is this trigger area over here. Now actually, I made an agent in one of my other Copilot Studio environments. I made an agent which is triggered actually. This one actually is a calendar agent, so it creates events on a calendar for my Scheibmeyer's fake restaurant. It books the party room, and it has the tools to get my calendars, to get the events on the calendar, so it doesn't make a conflict, to create events on my calendar. And I've given it a trigger when a new email arrives. Now there's all kinds of triggers that I could give it, right? I can make it like every hour or every day my agent wakes up on recurrence and it does something, or when a file is added to OneDrive or SharePoint, that it wakes up, or even third-party triggers, like if I make a record in Salesforce, then my agent wakes up and does something. Now this is a no-code environment, and I'm actually going to do something here. I'm going to use it in chatbot mode. So this is set to email mode, but I'm going to use it. I can also use it in chatbot mode, and that is a little bit faster than I could send it an email, but it takes a few minutes to propagate through the system. Book the party room on September 25th, 2025 from 7 p.m. to 9 p.m. Now, why am I doing this? Okay, so I'm going to let it do this. I'm going to fire this guy up, and you're going to see it start to work. And while it's doing that, let me open up my calendar over here. Where's my Outlook calendar? This one. Here we go. So I'll let it open up my Outlook calendar while this is working. Hopefully this signs in. Come on. This is my Alex Tanner test account. That is not a real person. And so it has created the event, 9/25/2025 at 7 o'clock. Now, let's see what happened here. Well, interestingly, I'm not going to change the time zone of this. Well, there's two events on here. I'm actually not sure which one this was. Here is a challenge that you have with no code environments like this. So I have two events on here. I'm not sure which one I just made. It made one of these two, but it does sometimes make this mistake. About 50% of the time, it makes the mistake where it puts it in the wrong time zone. Now, I specifically instructed this thing to make these things in Pacific time. It says it right there. All reservations should be made in Pacific time. And yet, some percentage of the time, it does not do that. It actually, I say 7 p.m. and it puts it at 2 a.m. Why is that? Well, what's happening here is that it's calling that create event API that I gave it. Sometimes it forgets to put the time zone in there. That thing does require a time zone. And, well, sometimes it just forgets to put the time zone in there. And if it forgets, then Outlook will make the event in GMT, in like London time. And that's why it shows at 2 o'clock in the morning instead of at the time that is intended. This is a fundamental limitation of a no-code environment like this. There's lots of stuff you can do in a no-code environment like this. And I'll tell you, like if you're making a question answering agent with this thing, man, you can whip that up in Copilot Studio in 2 seconds. It's no problem. But when you're integrating to third-party things, now I have a version of this. I'm not going to show it here today, but I have another version of this thing that is in code. I wrote it in code, and I know that this time zone thing is a problem. But in my code, I proxy the Graph API. So in my code, it doesn't just call the Graph API. It actually proxies it, and it looks for an issue where the time zone is not specified, and it puts a time zone in. It finds the current running user's time zone, and it pops that in there. So in my code, I can mitigate this issue when it arises. In a no-code environment, I mean, I probably could like make a tool in here that calls a Power Automate thing or whatever. There probably is a way that I could work around this, but whatever that is, it's probably beyond the scope of a business user, the kind of business user that would be using this interface in the first place. And that's why the majority of our customers that have agents in production today are doing it in code, because you have much more power in code, especially when you're doing these kinds of integrations, to mitigate the kinds of issues that you might see. Now, this is an agent that, and I'm actually going to fire this agent up. This agent is in Foundry, so this is our pro code environment, and this doesn't look like code. I mean, this is our web portal over here. Well, you can know that it's the pro code environment because there'll only view code buttons all over the place. I can literally open VS Code from here if I wanted to. But now I'm going to run this agent. This is an interesting agent, actually. And let me here, find me the latest customer in 2025 with a late delivery. Now, it is going to take a moment. I ran it in advance for that reason, because I knew that it takes a moment for it to run, because it's grounding itself to Microsoft Fabric. You see, I have connected this to the Fabric data agent, which I have right over here, which is now reloading itself for some reason. Now, the Fabric data agent is interesting. And actually, moreover, this as an architectural pattern is interesting. Whether or not you're using Fabric, that's not exactly the point. The point is this. Now, if we consider what's in this Fabric data agent, I mean, what it does is over here, you can see that I've given a bunch of data sources. So I have my semantic model, I got my KQL database, I got my, in this case is a mirrored Azure Databricks catalog, which looks to it like a SQL database. And I gave it a subset of the tables in here. So I said, here's a bunch of tables. And what it does, it creates a conversational interface over that data set. So I can ask the same question over here, find me the latest customer in 2025 late delivery, and here it goes, it spat it out. And how did it get to this? It actually had to do a lot of work there. So it made a SQL query first over here, and then it made like a KQL query over here, which is a totally different type of query language, and then it made another SQL query to get the person's name. And then finally it spat that out in its answer. So that's cool. That is actually not going to be the primary purpose of this agent. The primary purpose of this thing is actually to feed this thing. Here's the thing. What you do not want to do, you don't want to have each one of your agents writing their own literal SQL queries. If you think about this data agent over here, there's actually a lot of logic in here. I mean, there's logic about I have the different data sources themselves, but I also have the agent instructions in here, and the instructions will basically tell it all about what it should do and common acronyms and things like that. And you can also give it things like example queries. And so it's like, okay, if somebody gives you this query, here's the query that you're supposed to write and stuff like that. So there's a fair bit of logic that is encapsulated in this data agent. What you want to do is have an atomic data agent. Again, whether you're using Fabric or Databricks or Snowflake or whatever, you want to expose a data agent that your downstream agents can call, because you do not want to put that logic in every individual agent. It will break. It'll get out of sync. It'll break. All about the schema, the instructions, the example queries, all that kind of stuff, the different types of data sources, different types of queries. You don't want to do that. So what is emerging as a best practice now is indeed to connect your downstream agents to a data agent. And that is indeed what I did here. Now, the output of this thing is actually not meant for human consumption. So the Fabric data agent gave me a nice, pleasant response that was meant for humans. This one didn't, because I set it to do something different. What this is, the output of this is meant to be the input of another agent. Let me restart this guy over here. So this is going to fire up in a second. Okay, obviously wants me to pet it. Go. I'm going to tell it to go. So now hopefully this agent wakes up in a second. This is, if all goes well, is going to be a computer use agent. And this computer use agent is already doing something funny. Now, this computer use agent can actually use this entire computer. I have it connected to a Linux VM. And I told it to go to this website. Now, let's say I'm trying to file this delivery grievance. And there's no programmatic way to do this. I can't just give my agent a tool to go do this, because I literally have to go to their website and punch it in. So the output of my agent number 2 over there was to hear agent number 3, which is this computer use agent, which is using this computer to execute this stuff. So, and gradually, bit by bit, it is filling out this thing. Now, one thing to notice about computer use agents, they're not fast. I mean, the way that this is working is that, well, it's kind of like if you were directing an astronaut on the moon. And so let's say this astronaut is using a computer and it makes it, you say, click this, and then they click it, and then they send you a screenshot. And then you say, type this, and then they type it, and they send you a screenshot. This is what's happening. It's sending screenshots back and forth and back and forth. Now it has made a mistake, actually. You can see that it's trying to enter the delivery date, and it's clicking in the year instead, and it's starting to fix its mistake now. Why did it make that mistake? What just happened there? Well, it's the same reason, actually. So it's sending these screenshots back and forth. Now, sometimes it misidentifies the click target. So it misidentifies by a couple of pixels where it's supposed to click. In that case, what happens is, now in a date picker, you find this most starkly, because date pickers are quite compact. You know, if they're just a couple of pixels apart, the month, the date, and the year. So here, it went and clicked a few pixels off in the year area when it thought it was clicking in the date area. And again, bear in mind, like the astronaut, you're just saying, click here and type, but you don't see it until the screenshot comes back. So what happened there, it misidentified where it was supposed to click, and it clicked in the wrong spot. And that is the kind of error that you'll often see from a computer use agent. Now, in this case, it kind of self-corrected itself, although I think in the end it actually clicked on the wrong date. It brought up the little calendar picker thing, and that too was quite compact. And I think it clicked September 25th instead of September 26th. So they will make these kinds of mistakes. And this is all to say that a computer use agent, a CUA, is not a replacement for RPA, for UiPath or Automation Anywhere or Power Automate or any of that stuff. If you know the screens are going to be the same every time, use RPA. Do not use a computer use agent for this. They will make mistakes. Now, where it does come in handy, now, I have some friends at UiPath, and they have integrated this very model. The model I'm using in this case is Computer Use Preview. They've integrated this very model into UiPath, and one of their customers is using it. Their customer is testing Fortnite, like the game Fortnite. And the thing is, to open the game Fortnite, that's deterministic. They go find whatever the icon is, they click it, and it opens, right? But the play screen of Fortnite changes every time, and where the play button is moves all around the screen, even in different languages. You log in Russian, and the play button's over here. You log in English, it's over here. So then they send it over to the computer use agent, and they say, find the play button and click it. And so it does. It goes and finds the play button, it clicks it, it starts the game, and then they're back to their deterministic workflow again, where they're now testing the game and whatever they're doing. And that's kind of a way to go. In fact, I think you'll find that most production agents work that way, including the next one I'm going to show you. They are a blend of deterministic and non-deterministic. Now, somebody asks on the chat here, was the computer use agent created natively as well or via Copilot Studio? This one is not with Copilot Studio. So yes, in Copilot Studio, you can indeed spawn a computer use agent just like this. This one, I used it in the Azure way, where I actually provisioned, I brought my own VM, and I connected the agent myself to my own VM. So this is my own little, tool that I have it connected to like that. Okay, so yes, I'm watching the questions over here on my phone. How does it bypass auth layers? It does not necessarily. So you basically would have to give it various authentication. And you'll see that if you use like ChatGPT Agent, I just got Perplexity Comet yesterday, I haven't tried it yet, or Manus. If you wanted to authenticate as you have to kind of intervene and make it log in as you. So that is a thing you need to consider. And by the way, I mean, if you look at Manus, like when you ask Manus to do something, it is totally using a computer use agent over here. Like here, it went and browsed to Kotak, and then I was asking, some Indian folks about a loan or whatever, and it went and browsed all their websites. And that's what it does. It is actually using a computer use agent in the background here. And it does have those same challenges for authenticating as you. And if you look on my YouTube channel, by the way, you'll find one instance where I had a computer use agent, I had it running, I had it adding some sugar, buying some sugar for me, like a 10-pound bag of sugar. So it did that. And then it suddenly tried to log into Facebook, and I caught it on video, and I put it on YouTube. These things go sideways, and fortunately it didn't have my Facebook credentials. I don't know what it was going to do if it had logged into Facebook, but that was weird. So anyway, that is a thing to bear in mind. Okay. Now I'm going to tell you a story. Now, part of my job at Microsoft is I get these questionnaires. You see, I do all of our analyst relations. So Gartner and IDC and all these things, I do all these things, right? So any AI, like question, inquiry, whatever, comes to me. So I get these giant long questionnaires, actually much bigger than this one here, with all of these questions and stuff that I got to fill in. And about a month ago, I was like, that's it. I'm automating this. Forget it. I'm going to do this with an agent. And so I built this questionnaire multi-agent thing. Now, for those of you who know me, you might know that I had an earlier version of this questionnaire multi-agent that did work like this, where I could ask it a question like this and it gives me an answer. Now it gives me an answer and documentation and stuff like that. And now I have, this is entirely rewritten from scratch. And now I have an import from Excel button where I can give it an entire Excel spreadsheet and it will figure out where it needs to answer in the Excel spreadsheet and answer the whole thing, which it does quite effectively. The way that this works, there are 3 agents in here. So this is a maker checker pattern. So the first one is the question answerer. So the question answerer generates the answer over here. Then somewhere down here, we'll find that there is an answer checker. So here's the answer checker over here. The answer checker, its job is to look at the answer and approve it. And the third thing is a link checker. So it also emits links. Now the problem is, for whatever reason, these models hallucinate links like anything. So my link checker has curl and playwright and stuff, and it can check these links and make sure that they're valid. If either of the answer checker or the link checker say, hey, that's not valid. So if the link checker finds no valid links, as it did in this case, it goes back to the question answer. It's like, do it again. This time, give me some links I can use. And it checks the links again. It got all X's. And eventually, it went back and forth and back and forth. They argued for a while until finally it spat out a valid link, at least pertinent to this particular question. So that's how that works, maker checker pattern. And that's a reasonably common pattern for agents. But what's more interesting than this itself is how I wrote it. So here is the repo itself. This is a public repo, questionnaire agent v2. And I built this from scratch with structured vibe coding. So this is the spec that I wrote. And I did write this myself, this spec. This is not AI generated or anything. There's no emojis, no M dashes in here. I actually did write this thing. And this spec lays out what this is going to be. I mean, you think of vibe coding as being like, you go into the chat window here, you type whatever in here, and it codes that for you. And that's not the great way to go with this. So the 3 agents are the question answerer, that's the maker, and the answer checker, and the link checker. Those are the 3 agents that I have here. So you use this. This is, as we say, structured vibe coding. It starts with a spec. And so I gave it the spec. I'm like, this is how this is supposed to work. And I defined in the spec what these agents are, what they do, what their tools are. The question answerer, the answer checker have grounding with Bing search so they can search. The link checker has curl and playwright, stuff like that. And I also defined the workflow from, like, if you give it a direct question like I did a moment ago, and if you give it an Excel document. And then I gave some text specs at the bottom. I said, you got to use Azure AI Foundry exclusively, because that's the stuff that I get for free. So, I have a tendency to use that stuff. Anyway, and by the way, I made it use the Microsoft Docs MCP server. If you don't have this MCP server, you really should add it. And by the way, if you didn't know this is a little bit buried, but if you go to the extensions area in VS Code, I'm in VS Code Insiders here, but it's the same VS Code. Where did it go now? That's funny. There was a button right here. There should be a button right here. There is a site from which you can install MCP servers to VS Code without doing the weird manual way with JSON and stuff like that. So it used to be right here, and I don't know where it went now. So that's weird, but demo failed. But in any case, we're trying to make it easier to install MCP servers. The Microsoft Docs MCP server, if you're doing stuff with Microsoft things, is super useful because you can go look it up and go look up the details on whatever API it's hitting. So I gave it this spec. And actually, if I'm being perfectly honest, I gave the same spec, this spec, to 4 different things at the same time. I gave it to GitHub Copilot, Claude Code, Warp, I love Warp, and AWS Kiro, just to see which one would win. Actually, on the initial check-in, Claude Code won. So Claude Code actually gave me the thing that was closest to what I wanted it to look like. And out of the gate, it kind of worked, but not exactly. So the continuation of structured vibe coding is this. Now, at this point, I switched entirely to GitHub Copilot, and this is why I switched to GitHub Copilot. Look at all these issues. So as I was using the application, I found all of these various issues, and I logged all of these issues. Now, you'll notice on the side here, I have all these little Copilot icons. What's that about? These things, these issues, so if you look at one of these issues here, they have those icons because it was assigned to Copilot. So I literally I made the issues rapid fire, and I assigned them not just one at a time, but 3 at a time or 4 at a time to Copilot. So I'd give Copilot in a bunch, and I would say, okay, you do this, right? When you do that, you get the eyeballs here. So Copilot picks it up and it will start working the issue. So here you see it made a branch, Copilot fixed 34, I should say. And after 13 minutes and 4 seconds, now it does this kind of in the background asynchronously. You can watch it work if you want to, but you don't have to. So I gave it this issue with the screenshot and all this stuff, and I said, hey, I need you to fix this thing. And it made this code change in its branch. So now from this code change, it makes a pull request. We're looking at the pull request that it made, actually. And when that pull request comes in, so here is one pull request to a different issue that I have. Now, this is the GitHub pull requests extension I have to VS Code. This is where I can pick up the pull request and approve it, merge it. And when I merge it, the issue gets fixed. So you can kind of sync to it with this little arrow over here that picks up the code. And then I verify that indeed it fixed the issue. If it does, I merge it and we're done. If it does not, I can say at Copilot, fix this other thing, and it'll fix the other thing. And then it comes back to me again with the pull request. So that's what we're talking about, structured vibe coding. It means it starts with a spec, it continues with these issues, and it does create an effective way to manage multiple agents at the same time. Like I said, I had multiple different agents working on these things at the same time. I had a whole team of these agents. And so what this really is, when you really look at it, is this is a collaborative process. It's a process where I am collaborating with a team of agents. And this issues section provides the structure by which I can collaborate with these agents. And what this really approximates, the spec and the issues, it looks like a normal development process, like you do with humans. You give humans a spec, and then you have these issues, and you divide them up, and you send them out to people. That's what it is, except that I was a team of one. Well, one me, and many agents. And so, last but not least, I did promise you that I would show you a usage of GPT real time that is in a real application, and this is it. Now, what you're looking at now, well, a little backstory on this one. In 2021, NASA launched a mission called DART. Now, I actually, as part of my job, I spend a lot of time with space agencies, which is actually part of the coolest part of my job. So in 2021, NASA launched this mission called DART. And the idea was for it to impact this asteroid. It's actually a small asteroid orbiting another asteroid called Didymos. So it's the Didymos system. And they impacted this asteroid. The name of it, I don't remember the name of the asteroid they impacted, but they crashed a spacecraft in 2023 into this asteroid and deflected it. It blew a whole chunk off the side of it. What you're looking at now, this is the Hera spacecraft that we see here. The Hera spacecraft was launched in 2024 by the ESA, the European Space Agency. And its goal is to go to the Didymos system and measure how far did we deflect that asteroid with that impact. Because, well, for one thing, there is an asteroid that is heading towards Earth in 2029. It may not actually hit Earth, but if we determine as it gets closer that it will hit Earth, we would really like to be able to deflect it before it causes a mass extinction. So that's what makes this mission important. Now, why are we looking at this thing? Here is why. Hey, so where is the spacecraft relative to Earth right now?
Million kilometers from Earth. Take a look at this visualization that shows my current position in space, cruising toward the Didymos system.
Cool. Hey, so what is the temperature of the spacecraft right now?
Take a look at these plots that show my recent temperature readings. For instance, my solar array drive mechanisms, SADM temperatures range from about minus 67 degrees Celsius to minus 65 degrees Celsius. So it's quite chilly out here in deep space.
All right, that's a bummer. Want to know? It got a little error here, but can you show me a video of the launch?
Here's something exciting for you. On Instagram, there's a fantastic post showing launch day photos from my big moment. You can see the SpaceX Falcon 9 lifting me off from Cape Canaveral on October 7, 2024. The post mentions that by 1652 CEST, I left Earth behind, and by 1812 CEST, my first signal was received by NASA's Goldstone station.
All right, you be quiet. Now, unfortunately, we had a minor demo fail there, but my point about all of this is that this is a fully interactive environment here. So this is not just chat, and you can chat to it also. And the voice thing is not enabled for everybody. So if you try, now you can do this yourself and show it to your kids, Hera.space. It is pretty cool. This is indeed linked to the live telemetry from the spacecraft. So this is the literal telemetry data from the spacecraft right now, wherever it is now approaching the Didymos system. And Oh, well, there we go. It's picked it up now. Now, what I was trying to make it show was a temperature chart, so which it was trying to show, and it seemed like it got some kind of an error there. But this is interactive. So when I ask it questions about stuff, it's not just answering the question. It's like, hey, here's my chart, or here's it did show the orbital paths. It showed that Instagram post and those kinds of things. It can show sometimes some YouTube and that kind of stuff. This is where this is going next. These AI interfaces, I mean, you think of things like Copilot and stuff like that, and right now they're relatively static. They're like chat interfaces. You talk to them and they talk to you. That's it. But where this is going to go is more towards these fully interactive applications. And this is a kind of a front runner among them that shows how we are going to interact with these things. It's not just going to be chat and talking anymore. It's going to be a full screen application or on your phone or whatever that interacts with you and with visuals, with interactive stuff. This is where this is going to go. This is actually a full Azure Foundry stack over here. So there's Foundry at the top, GPT real time. It's using tool calls to call all of this stuff. And it uses, and it has a memory too. So if I look at its memory of me over here, well, okay, it has no memory. Okay, I'm having some failures here, and that actually might be the conference Wi-Fi here. But it does keep these memories of me in its Cosmos DB over here. So it knows who I am and languages I speak. And so if you have a 5-year-old interacting with it and your 5-year-old's like, yeah, I'm 5 years old, it's going to talk to the 5-year-old like a 5-year-old. It's not going to say like the current temperature of the spacecraft is 66 degrees Kelvin or something. It'll be a little bit more adaptable. So anyway, this is what the future of AI actually holds. And these are the kinds of things that you're going to see in the next generation of AI-enabled apps. And with that, I believe I am out of time. So I don't know, Vesa, you can tell me if I have time to take questions or whatever. I see we actually have a number of Finns on here, so maybe more of you understood the Finnish than I thought we were going to.
Thank you, Marco. That was excellent. Yes, you still have time. Donna is going to be the next one here, but she's not here yet, so don't worry. You can have time for questions.
So and while we're doing that, I'm going to put a link to the repo in here, and I'll put a link also to my YouTube channel, so y'all can. So there are videos of some of these things on my YouTube channel. Actually, I have many more than these videos on my YouTube channel, and I post new ones fairly frequently. So yeah, if you have any questions, feel free to put them in the chat, or you can just raise your hand. I don't know if people can actually. We're live, right? So I don't know if people can raise their hand.
They can raise a hand, and we can also enable mics if that's wanted. So we have full control on allowing mics. But raise hand is a good one. So if you want to ask a question, please raise hand or just put to the chat. That's quiet, but that was a great presentation. It was a very pleasure to follow and to see also all that what Azure can do. And I have to say, I admit I didn't try the video translator earlier, so I need to try to check that out.
That's right. You can make yourself speak any language you want.
Yes, I did that, but with a few other tools. Back to the Baltic Summit, I had a personal voice used, and then I had used the DID to create the video, but then I could have just skipped that part.
Yeah, you can make yourself speak all those other completely unrelated Scandinavian languages, right? You can do Swedish and Danish and Icelandic and stuff. I guess Finnish and Estonian are pretty close, I think, but yeah.
Well, we don't still understand each other, so.
No, I tell you. This is a little. I think I told you this before, Vesa, but I'm a big Pesapallo fan.
Yes.
So I do love that when I'm in Finland to check out those games, man. For those of you who don't know, there is a totally different variant of baseball that is played in Finland. No place else in the world do you see this variant of baseball, but it is much faster moving than American baseball. It moves very quickly, so it's a super fun game to watch.
Yep. Hopefully you will join us in Finland one day to watch a game or two.
Certainly hope so.
I just want to say, Marco, this was one of the greatest sessions I have attended in a very long time, honestly. And giving you 1 hour is just like, we're not doing you justice. We need more. We honestly need more. I personally need more.
Yeah.
And you see all of these questions? Yeah, that was me.
Well, now, actually, so on my YouTube channel, I mean, there actually is more. I mean, I'm not going to do it today, but there is a whole another hour I could do actually on other stuff too, because what I didn't
Please,
really get into today, there's a whole, like when you think about putting an agent into production, there's a whole bag of things you need to do around evaluation, observability, monitoring, cost monitoring, all this stuff. I actually did put a video on YouTube about that recently, also. So that's a whole ball of wax unto itself. And then there's also the topic of the reasoning models and using those effectively. Here, most of my other presentations today have to do with financial services. SimCorp is a provider of financial services, and I have another keynote in 10 minutes that is also to a financial services company. And their reasoning models can be very effective in that environment. You can use them to make like buy side or sell side reports. You can use them to do investment analysis. In fact, I do use O3 to do analysis on my own investment. So I didn't really have time to get into that here today, but that is a topic unto itself. It is at least some of it covered on my YouTube channel. But yeah, the structured vibe coding stuff. Oh, by the way, I didn't mention this. I forgot about this. Spec Kit. So if y'all haven't seen this, what I did. So let me see if I can pop that in. So I put this in the chat. Spec Kit is now public. So I wrote that specification myself, as I said before. When I did the whole structured vibe coding thing, I wrote that spec myself. And that's for those of us who are on that kind of leading edge of structured vibe coding. That's what we're all doing right now. We're all writing our own specs like this. What is going to happen is these development tools are going to start to evolve in that direction where they're going to help you write the spec too. And so, for example, like I wrote this whole spec and I wrote that section about what it does when it gets an Excel file. I did not tell it what it does if there's a password protected Excel file. Now, if I had a kind of an interactive spec writing tool, which SpecKit is starting to approach that, then it could be like, so what does it do if it's got a password on it? Then what does it do? So it can help me write a better spec from the beginning. Now, SpecKit right now, the way that you use it is kind of CLI-ish. I definitely recommend you all look into it. In fact, some folks I've been talking to have started using it and speak well of it. Written originally by Den Delamarski on our team. But you're going to find that more and more, this is actually going to enter the user interface of the coding tools themselves. So there will be a first-class representation of a spec, and it will kind of encourage you to use this kind of structured vibe coding as a best practice. So that is SpecKit.
That is super insightful. I think we have a lot of things to explore, Vesa. We have a lot of things to explore.
Yes, we have a lot.
So I had a question, Marco, regarding the data agent on Fabric. I just wanted to know. So you have one data agent on Fabric that is communicating with another agent that is created on the agent service on the Foundry. And you mentioned something related to the scheme. Do not define the scheme, the SQLs, the queries. Do not define the agent to do that behind the scenes. I think we're losing Marco. Yeah.
You lost me for a second. I'm back now, I think. I hope I'm back.
Yeah,
so evidently my hotel decided my presentation is over. They're like, oh,
it's over.
That's it.
Yes. So my question, Marco, was the agent part. You mentioned that there is a data agent on Fabric that is communicating with an agent on agent service, right? On the Foundry, right? And you mentioned that there is something related to the SQL definition part, the schema part. Do not put the schema there. Do not define the tables within the agent. You mentioned something related to that, right? I just wanted you to elaborate on why wouldn't you want this to happen on the side of the data agent.
Now, actually, I do have a YouTube video that kind of approaches this that I've been meaning to remake now in the agent world, because I actually made it before, when agents were brand new, about a year and a half ago. The reason is the amount of logic that it takes that you have to give to an agent for it to effectively query anything, whether that's a SQL database, a KQL database, whatever it is. There is just a vast amount of logic that you have to put in there to make it accurate, like the data dictionary and or however you call that, right? Your data definitions. And as I said, the special instructions, like acronyms that you might give it. If I ask it what the ISR is, and if that's a thing for you, then you have to know what that is. Or for us, ACR, right? ACR, Azure Consumed Revenue in Microsoft world, right? But my agent won't know that. So if I'm going to have many different agents, let's say I'm going to have like tens or hundreds of different agents, and they're all doing these SQL queries, the problem is I'm going to have to endow them all with these things, with this logic, and then I'm going to have to keep it up to date across all of them. And that's not going to work. You know that's not going to work, right? You're going to miss a bunch of them. They're going to start to fail. You're going to change your schema, and they're not going to know it, and it's just going to be a mess. Whereas if you connect them to a downstream data agent, it also makes your trace much cleaner. Like when you go look at the trace, and I didn't go into tracing here today, but if you go look at the trace, you'll see, oh, okay, it called the data agent, here's what it got back, right? Versus when it tries to do queries and it gets all messy in there, what it did. So it gives you kind of a single place where you can debug that data access layer that is isolated from the remainder of your agents that basically focus on what those agents are supposed to be doing. So it gives those agents, the downstream agents, a conversational interface where they don't have to go write these queries and things like that. They can do what they're doing when they need structured data, go call Fabric data agent or whatever data agent you have set up. But my point, again, more generally, is not just with Fabric, but in general, it is the best practice to isolate and have an atomic data agent that your downstream agents can call.
Do we happen to have any practical tutorials on these specific bits, Marco, related to the creation of these agents, the architectural patterns that you mentioned?
I can't say that I do. I'm sure my colleagues in Fabric do. We just did FabCon in Vienna last week, and we actually did this. We set up just this data agent that you looked at. We set it up live on the stage there. It doesn't take that long to set it up, although there's a long tail of like adjustments you need to make to get it to work the way you want it to work. So I mean, I think if you look for Fabric Data Agent on YouTube, you probably will find good examples of that. But I haven't presently put them on my channel. And so with that, I do have to get going here because I do have another keynote coming up right now. So I will see you all later on and have a good day.
Thank you, Marco. Thank you.